faced with a graph like this, the first thing I do is look at the data set. What is the data set actually talking about? It gives me a title of the data set, it gives me the thing that changed, and it gives me the thing that measured with a label. Okay, great. I'm going to make a graph of the population of Portland, Oregon over 60 years. Now, when I want to make a graph, I have to remember my tails. I'm actually going to write that down to remind myself. T-A-I-L-S. You also have to remember to plot your data points well. So I'll make that mark down there too. All right, so the first thing, T stands for tails. The data table gives me the graph title, the population of Portland, Oregon over 60 years. So I can write it up here. We want a title that clearly tells the people who are looking at your graph what it is that they are looking at. So this graph is going to be the population of Portland, Oregon. Awesome. The next thing down is the axes. Remember our acronym DRYMIX? This tells us that the independent variable goes on the x-axis and the dependent variable goes on the y-axis. The independent variable is the thing that changed and the dependent variable is the thing that we measured. In this graph, the thing that we measured is, or the thing that was measured is the population, and the thing that changed is the years. On this particular graph, I actually told you that you are going to put, in the test, I reminded you that you're going to put the population on the y-axis. So we can just label that right away. That on the x-axis is going to be years, and on the y-axis is going to be population. Great, we've got our axes and we've got even some of our labels. We're going to skip down to scale. Scale is how high the numbers go on either axis. And remember, to find this, we look at the maximum in our data. We look at the minimum and the maximum. So the x-axis, the years, has to go from 1960 to 2010. And on the y-axis, it has to go from 372,000 to 583,000. So on the y-axis, the highest number has to be more than 583,000. So I know that my scale is going to go up to at least 583,000. So now it's time to look at our intervals. Our intervals are what each box is worth, what each line is worth. It's the amount of numbers in between each mark on the axis. So on the x-axis, we have to make sure that there's space for 1960 up to 2010. I'm just going to take a guess. Maybe we'll place these years every 2 boxes. So if we do 1960, 70, 80, 90, 2000, 2010, yeah, that's going to work. Okay, so we'll write them in there, 1960. So this doesn't go all the way from one end of the graph to the other, but it mostly fills the space. This is good. All right, the y-axis is going to be a little more tricky. But I showed you that you're going to start at 340,000. And you have to get all the way up to at least 583, 590,000. I always recommend trying to start with counting by 1s, 2s, 5s, or 10s. So if we were going to start with counting by 10,000s, 350,000, 60,000, 70,000, 80,000, 90,000, 400,000, 10, 20, 30, 40, 50, 60, 70, 80, 90, that doesn't get us there anywhere near enough. What if we did it by 100,000? So 340,000, 440,000, 540,000, 640,000. Well, that would work, but all our data would be squished in this little area. So that's not going to work either. What about by 20,000s? 340,000, 360, 80, 400,000, 20, 40, 60, 80, 500,000, 20, 40, 60, 80, 600,000. Hey, that would get us more than 500,000, and it fills up the space. Again, it doesn't go all the way to the top, but it fills up the space. That seems pretty good. 100,000. Okay, so now we've got our intervals and our scale. And when we named our axes, we took care of the labels as well. Great, we're ready to move on to plotting points. So for this, we need to be very careful and very thoughtful to make sure that all of our data gets put where it belongs on the graph. So our first data point is over to 1960 up to 372,000. Over to 1960 up to 372. 360, 380. So halfway is going to be 70. Just above halfway is going to be 372,000. Great. Next point is over to 1970 up to 382,000. Okay, 380. That would be 390, so we're going to be just right there. 80, and I got to make sure that I didn't skip any lines or anything. 583,000. Great. Now the very last step, because this is a line graph, not a scatter plot, we're actually going to connect these lines. These dots represent the same thing. It's the population that has changed over time, so we carefully connect the dots. Now, if someone asked you to look at this graph and see what was the population in 1965, because we have even intervals here, this line is 1965. And because we have even intervals here, we could come over and say in 1965, the population was about 395,000. If we wanted to know what it was in 2005, we could go up here and over here. If you don't have your intervals even, you can't read a line graph like so. Now you plotted your data too. Here you go. Here's your beautiful finished graph.